Good morning to you all. Welcome back to physics class. In the last class we were discussed about Lorentz force, Lorentz magnetic force and Lorentz electric force. Today we are going to start a new topic, magnetic force on a current carrying conductor. Okay, I hope all of you studied the previous topics very well. So now let's start our class. So the first topic is magnetic force on a current carrying conductor. Okay, so here PQ is a conductor carrying current I in the positive y direction, and the magnetic field is acting along the positive z direction. So the conductor carrying current I and also magnetic field is acting on that conductor. What happened? A force is experienced by that conductor. The direction of the force is positive x direction. Okay, then now we have to assume that the length of the conductor is L and area of cross section of that conductor is capital letter A. Okay, then N is the number of free electrons per unit volume. So what is N, small letter n? N is the number of free electrons per unit volume. So what happened to total number of free electrons? So total number of free electrons, so total number of charge carriers, capital letter N is equal to what? N is equal to small letter n into volume of that conductor. So how can you find out the volume of the conductor? You know that area of the conductor is capital letter A and length is L. So how can you find out the volume? Volume is A into L. Okay, so capital letter N is equal to what? N into AL. And also one more thing, the electron drift towards left with velocity Vd. So what is the Vd? Vd means drift velocity. Okay, and also find out the charge of the charge particles. So it is Q. Q is equal to what? E into NaL. That means total charge of the conductor. Q is equal to what? E into NaL. Here E means charge of an electron. Okay, NaL means total number of charge carriers. Okay, then also you know that the Lorentz magnetic force F is equal to Q into V cross B. Okay, so here Q is what? E into NaL. So you have to write the values of Q. So what's the value Q? E into NaL. Then here velocity means drift velocity Vd cross B. Okay, so F is equal to what? F is equal to E into NaL Vd cross B. Also you know that current density J is equal to what? I divided by A. I divided by A is equal to Ne into Vd. You already studied it in your third lesson, current electricity. Okay, so here you have to rewrite this equation. F is equal to N E Vd A L cross B. Okay, and also you see here N E into Vd is what? Current density J. So you have to write the value J. Okay, J into A L cross B. Okay, and also what is J into L? J into A. J into A means I. So see this equation, J is equal to what? I by A. So what is I? I is equal to J into A. So which is equal to what? I into L cross B. Okay, which is equal to what? I into LB sin theta. That is F is equal to what? F is equal to ILB sin theta. This is expression for magnetic force on a current carrying conductor. Okay, so you have to write in a vector notation. Vector F is equal to I into L cross B. Vector L cross B. Okay, then now we discuss about special cases. So the first case is if, so tell me what is theta? Theta is the angle between the direction of the magnetic field B. Angle between the direction of magnetic field B and the direction of the flow of current. Okay, so what is theta? Theta means the angle between the direction of the magnetic field B and the direction of flow of current. Okay, so the first case is if theta is equal to 0 degree or 180 degree. So what happened to F? Magnetic Lorentz force F is equal to I L B sin 0. Sin 0 means 0. So what's value? F is equal to 0. Okay. So thus a current carrying conductor placed parallel. A current carrying conductor placed parallel to the direction of the magnetic field does not experience any force. Okay. So F is equal to 0 means it does not experience any force. And the second case, if theta is equal to 90 degree, then what's the value of F? F is equal to I L B sin 90 degree. Okay. So which is equal to what? I into L B, that is F is maximum in that case. Okay. So thus a current carrying conductor placed perpendicular to the direction. Placed how? Perpendicular to the direction of a magnetic field, it experiences a maximum force. Okay. So magnetic force on a current carrying conductor is what? F is equal to ILB sin theta. Okay.